Good morning. My name is Aryan Singh Rana, and in today's video, I'll be explaining you the solution for the LeetCode question number 225 with the title Implement Stacks using Queue. Now, the question is pretty simple. Says that implement the last in first out LeFo or concept stack using only two queues. The implemented stack should support all the functions of a normal stack: push, push, top, pop, and empty. Implement my stacks class. Void push. This is the name of the function push. Int x pushes the element x to the top of the stack. Int pop removes the element of on the top of the stack and returns it. Int top returns the element on the top of the stack. Boolean empty returns the true if the stack is empty, false otherwise. So this question is pretty simple over here. We just need to implement we need to use the queue, and queue is based on the concept of first in first out, and we need to use the queue data structure to implement all the functionalities of stack. As we can see that this is the sample input over here, and let's simply go to the explanation, because we don't basically do not need to worry that much about the what comes in the input. We just need to develop the function for it to perform like a stack function. So as we can say in the input, if we apply dot my stack dot push one, then it should include one element inside my stack, and if we use top, then it should return the topmost element inside the stack, which is the last entered element. So should return two, because we in the previous command we pushed two inside of it. And in the last one, we are simply popping it out, and which will delete the element 2 from the stack, and the last command is stack.empty, which would return false, because it contains as an element inside the stack, and it would return true if the stack was completely empty and didn't have one in it. So first I initialize not initialize first I declare two queues which will contain the integers data type, which is q1 and q2. I haven't initialized them yet. I simply declared them outside, as you can see, outside every function, inside the my stack class. After that, you can see this is the public class my stack, which would initialize the both of the stacks, which is q1 and q2. And as you can see that I have initialized as like a new linked list. This is the syntax for the q1 and q2, or for initialization of q1 and q2. After that, here comes the main thing. This is the where all the source for implementing queue to use it as a stack comes from. Now, what is happening over here? First, I am emptying out whatever element is inside of Q1 into Q2. Then I am pushing the new element that is coming from the input inside the Q1, and then I'm emptying out the Q1, Q2 to Q1. Now, what would happen? Going to simply show you like this. For example, let's say we have a stack, we have a queue which contains numbers like 1, 2, 3. Now, if we use pop, push, or if we use, for example, let's say we use pop. Now, because it is a queue, then it would simply remove the first element that we enter, which was 1. But we are using queue as a stack over here. So what we need to do is that if we use queue dot pop, then it should remove the last element. Now, how would that happen? That's where the role of the second queue comes in. Now, what we are doing is that let's say this is our Q1, and this is our Q1, and the Q2 that we just initialize is this one. Now we are using a loop. As we can see that in the loop, we are saying why Q1 is not empty. This exclamatory mark is saying that not empty. So if it returns false, then the while loop it will continue, will keep on iterating until Q1 is empty. Now what is happening is that I am pushing I'm pushing the values that are inside the Q1 into Q2, and so yeah, Q1 dot offer puts the element inside the Q2, and Q1 dot poll returns or pops out the first element that was entered inside the Q1. So how the process is running over here is that, as you can see that this was our Q1 and this is our Q2. So while loop will first check if Q1 is empty, so it is not empty. So it would first implement this command which is inside of it, which is q1 dot poll, which would return, which would pop out one from it and enter it inside q1. So I am entering q1 inside of it. Now after that, again the while loop will check if Q Q1 is empty. No, it is not empty. So it would again pop the first element, or you can say the second element that was entered inside the Q1, and it would simply enter it inside the Q2. So now it would be like this, and both these elements have been removed. Now again the same process would repeat, and three would be entering now over here. Now our Q1 is empty though, so while loop would stop over then and there only. So what would happen is that after that I am simply whatever the new element that is coming from the input would be directly entering the empty stack, which is our Q1 that we emptied out just recently, and it would enter it. For example, let's say 4 was our last element, that latest element that was inputted or given us from the input. So it would go inside the Q1. Now, what we are doing is we are simply reversing the process. How we are reversing the process? We are simply now repeating the same process, but now for Q2 from but now the elements from Q2 would go to Q1. So as you can see that the loop is the commands are almost same, but the things are over here are different. So yeah, as you can see that the loop is exactly same, but simply we are emptying out this time, emptying out the Q2 and pushing all the elements in Q1. So let's simply repeat the same process from over here. So while loop initiate for the Q2, and the first pole would return one because that this was the first element that was entered in it, and the Q works on FIFO. So first one would enter and one would be removed from here, and after that Q would enter to Q2. Now 3 would enter Q3 and the Q2 would be empty. Now here what things get start to get interesting. Now remember 4 was the latest element that was inserted inside a Q2 or Q1, and we are using the Q1 as the stack over here. Now what is the concept of the stack is that whatever element is entered last would be the first element that would be popped out of it whenever we call the pop function. Now, what for the Q1, we know that whenever we use the poll or pop function, it returns the first element that was entered inside it. Now here you can see that the order has changed. So when we call pop or poll for the Q1, what it would return? It would return 4 over here because before any 1, 2, 3 elements were added, 4 was the first one that was added, and 4 would be returned. Now, as you can see that just because of simply swapping, or you can say first emptying out the Q1, then entering entering the new input in the Q1, and then emptying out the Q2 and putting all those values inside the Q1 simply makes the Q1 as a stack. And when we use normal Q function over here, now this would behave like a stack over here. Now if we use dot peak over here, it would return 4 over here. But for the overall user, the user would simply think that, okay, I entered fourth, the last number that I entered is fourth, so peak value should give me 4. And that is the functionality of stack. But as you can see that the internals say that we are using the queue for the stack. So that's the most interesting source all about it. That just with the use of two loops and an extra queue, we can convert a queue into a stack. And after that we have used multiple different functions over here. This is for pop. So as you can see that as we have made q1 as the stack using the queue, so we are only performing all the stack operations inside the q1, not the q2, because in the end of the second while loop the q2 is now empty. So as we can see that the it is a pop function and it is returning the q1 dot remove, and as I told you in the it would return the latest element that was inserted by the user or whatever the input gave. So it would simply return that, and the top would simply give us the front of the whole queue. And because the 4 was the first element inside the Q1. After emptying it out and refilling it, the fourth was the last. According to the user, the fourth was the last element, but for the Q1, it was the first element. So it would return 4 as the answer, and is empty the normal function. It is a universal function which works the same for Q and stacks as well. So that's all the coding part. Now simply running the code. As you can see, my all the test cases have been passed, and I'm now simply submitting all the code. Now, as you can see that my code has been successfully submitted. Now, coming to the time complexity of this whole solution, the commands like return q1 dot remove q return q1 dot element and return q1 dot is empty are of constant time complexity because it takes O of one time complexity only. But the most inefficient part of this code is about these while loops, which is running till the length of the queue, and that's why the time complexity is dominated by this whole these whole two while loops. So the whole overall time complexity of this whole code would be O of n, where n is the length of the queue. Well, that's all for the solution for this question. Thank you for watching.